In 2015, two large storm events occurred in McCurtain County, Oklahoma, leading to damage of personal property, but more importantly, the complete transformation of a popular trout fishing stream. The floods were not entirely natural events as they occurred below a controlled spillway of Broken Bow Lake. The forested location of Broken Bow Lake in the adjoining Beavers Bend State Park has become a popular destination for fly fishing for rainbow and brown trout. Additionally, the nearby area known as Hochatown has rental cabins and restaurants to complement Beavers Bend State Park campgrounds. McCurtain County is located in far southeast corner of Oklahoma and situated in the Ouachita Mountain Range. The Ouachita Mountains consist of generally east-west trending steep-sided mountains with elevations ranging from 600 to 2,000 feet above mean sea level. The spillway contains 8 gates which allow cooler water to drain from near the bottom of the lake. The water from the spillway flows into what is known as Spillway Creek, which joins Lower Mountain Fork River approximately 1.5 miles downstream. Due to the cold waters emerging from the spillway, trout can survive year-round in Spillway Creek and Lower Mountain Fork River. Two separate flood events occurred in 2015 in May and December. The results of the flooding left Spillway Creek wider and shallower with less vegetative cover. This change to the stream resulted in the greater heating of the water from solar radiation during the warmer months, which reduces survival chances of the trout year-round. During the month of May, McCurtain County received between 10 and 20 inches of rain. Leflore County, Oklahoma, where the headwaters of the Upper Mountain Fork River are located, received greater than 20 inches of rain. The departure from normal for precipitation during the month of May was greater than 8 inches across all of southern Oklahoma. The month of December 2015, rainfall ranged from 10 to almost 20 inches across the watershed. The departure from normal for December 2015 ranged from 5 inches to greater than 8 inches across McCurtain and Leflore counties. When looking at the reservoir pool elevations in May 2015, the lake level dropped below 609 feet on May 7th and 8th before steadily rising to nearly 625 feet on the 24th of May. On May 25th, 2.41 inches of rain fell when the lake was already at capacity. As lake levels continued to rise to near 620 feet on the May 19th, an increase of releases could have prevented the extreme flooding that occurred 6 days later. The total releases on May 18 were the lowest over a 2-week period. As 2.41 inches of rain fell on May 25th, which was also Memorial Day, the lake releases exceeded 27,000 day-second feet, known as DSF. An additional 1.43 inches of rain fell on May 26, and the releases remained above 25,000 DSF. The December storm and subsequent flooding came as a much greater surprise than the May event. During the morning of December 27, the lake level was at 614 feet, and by midnight, the lake was approaching flood pool capacity at 623.72 feet due to 2.5 inches of rain. The total releases on the 27th of December were limited to 1,700 DSF, which was significantly lower than each day of the preceding week. On December 28th, the 24-hour rainfall total was 5.77 inches, and the spillway releases totaled 29,886 DSF, which is when the greatest flooding occurred. Only a trace of rain fell the next day, and releases remained above 23,000 DSF. From a review of lake levels, rainfall totals, and spillway releases, many lessons can be learned from the Lower Mountain Fork River flood events of 2015. Additional releases from the dam could have been conducted during the days prior to the May 25th flooding. The lake levels rose much more rapidly during the December flood event, a total of 9 feet in one day, Increased spillway releases on the 27th should have occurred, although they may have not made a huge difference in regards to the scope of the flooding, as nearly 6 inches of rain fell the next day. The storm and flooding event show the importance for lake managers to understand how hydrometeorological events lead to rapid effects on surface water. Close coordination is required between lake managers and storm prediction experts.